Hong Kong is a city with high building density. Buildings consume about 90% of Hong Kong's total electricity consumption and contribute around 60% of carbon emission. You can imagine how much energy-saving potential there is. In view of this, the government has taken lead to promote and implement retro-commissioning, which is a systematic and cost-effective energy management measure in recent years. RCX can help to identify energy-saving potential and improve the performance of the building services installation inside the building, which is due to the deviation between design and actual operation, change of usage, behavioral change of occupants, etc. This video will illustrate RCX measurement procedures for HVAC Airside system and provide examples. This video will cover 4 aspects, including 1. Importance of measurement, 2. Measurement items for HVAC Airside system, 3. Measurement procedures, and 4. Identification of potential energy-saving opportunities. Measurement plays a vital role in retro-commissioning. 3 key processes are involved, including 1. Collecting trend log data to understand the operation of central building services installation. Checking the sensors and control of the central control monitoring system to see if replacement of defective parts is required before measurement. 2. Analyzing trend log data. And 3. Identifying potential energy-saving opportunities. Before formulating the measurement plan, it is necessary to carry out on-site inspection and preliminary checking of the HVAC system. Permission should be obtained from the person responsible for the premises, and they should be informed of the impact of measurement work. Also, the measurement plan must cover all required measurement items, relevant equipment, and measurement areas. Next, a comprehensive measurement plan should be formulated to ensure measurement can be conducted smoothly. The measurement plan should cover system and equipment to be measured, location and measurement items, etc. Once the plan is formulated, it will be submitted to the responsible person for approval, so relevant data can be obtained for subsequent analysis. Meanwhile, in order to effectively compare the parameters set by the CCMS against the actual indoor environment, IoT technology can be adopted to measure room temperature, humidity and light intensity. First, an IoT measurement plan should be formulated for the buildings based on the served areas of the HVAC system equipment. And then various types of IoT sensors should be installed inside the designated rooms. If the actual room temperature is below the CCMS set point, whether the room is in use or not, this means there is excessive demand for air conditioning. The relevant settings can be optimized to achieve energy efficiency and reduce unnecessary energy consumption. Approval from the responsible person for the site is required for the installation of smart sensors. Also, the sensors should be installed at suitable locations to avoid affecting users. In the next section, common measurement items for HVAC Airside system will be presented in detail. Measurement items for air handling unit include return air temperature and its relative humidity, supply air temperature and its relative humidity, indoor CO2 concentration, equipment power consumption. The above measurement items help to check the power consumption and efficiency of the overall HVAC Airside system. Meanwhile, the measurement of indoor CO2 concentration can help evaluate indoor air quality. If the indoor CO2 level is low, it means there is excessive fresh air supply, and the amount of fresh air can be adjusted to save energy. Measurement items for primary air unit include fresh air temperature, supply air temperature and power consumption. These measurements help to understand the operation pattern of the PAUs. Since hot and humid fresh air increases the overall cooling load, especially in summer, proper control of the fresh air intake will help to reduce the cooling load as well as the fan power of the PAUs. For the fresh air fans, exhaust air fans, fan coil units, variable refrigerant volume system and split air conditioning units, their power consumption can be measured. The accuracy of the data is very important, as it has a direct impact on the subsequent data analysis and identification of energy-saving opportunities. Therefore, the central control and monitoring system log sheet should be checked to see if there are any abnormal data and to understand the current status of operation, including whether the AHUs or PAUs are switched on or off. the speed of the variable speed drive, return air and supply air temperature set point, cooling valve open position, and etc. Common measuring instruments can be divided into wired and wireless loggers. Wireless loggers can be used for outdoor area to measure temperature, relative humidity, and CO2 concentration, while wired loggers includes data loggers and current transformers, which can be used to measure temperature, relative humidity, light intensity, current, voltage, airflow rate, and so on. Meanwhile, recording intervals can be adjusted according to the technical guidelines on retro-commissioning established by the Electrical and Mechanical Services Department or the client's needs. Based on individual circumstances, different types of sensors and recorders can be used. Before conducting the measurement works on site, RCX team shall be aware of the following items. RCX team will conduct measurement once they have obtained the responsible person's approval for the site measurement plan, the IoT equipment measurement plan, as well as valid calibration certificates for measuring instruments. Before conducting electrical measurement, competent personnel should be appointed, such as registered electric worker of the appropriate grade, registered professional engineer of the electrical or building services disciplines, or registered safety officer, to assess the electrical safety of carrying out live work and to recommend appropriate control measures. Information such as the completed electrical safety assessment form and work permits should be submitted. Each electrical measurement should be carried out by a registered electric worker, and a completed work completion certificate WR1 should be submitted afterwards. The RCX team will then meet with the person responsible for the premises and brief them on the overall measurement work to ensure they have a clear understanding of the workflow. Then the RCX team will locate the HVAC Airside system that needs to be measured according to the approved measurement plan. The RCX team will set up the data loggers based on the location in the measurement plan approved by the client and carry out subsequent measurement. Next, the temperature and humidity sensors will be installed at the test points of the AHUs and PAUs, including supply and return air locations. The data readings will then be verified and the logging is started. For measurement of HVAC airside equipment's power consumption, the RCX team and the registered electric worker should firstly locate the local motor control panel of each HVAC airside equipment. Upon carrying out measurement without electricity suspension, the registered electric worker must take all necessary safety precautions, such as wearing insulating gloves. Next, the registered electric worker will install a current transformer and data logger in the LMCP. Upon logger installation, the LMCP panel shall be reinstated, and warning labels should be attached to a visible position on the panel to remind other personnel not to interfere with the measurement. A photo record should be taken at the end of measurement works. The RCX team will first install an IoT gateway at a location where a good signal is received. Once the gateway is set up, the RCX team will verify the network signal to ensure the IoT gateway is well connected to the data server. After that, the RCX team will install IoT sensors according to the IoT measurement plan approved by the client to ensure the sensors can carry out data logging without disturbance, as well as minimize the impact to the normal operation of the premises. The IoT sensors will be installed on the electrical conduits or return air grills. Upon sensor installation, the RCX team will check if the smart sensors are successfully connected to the IoT gateway, and the logging data should be well received and extracted from the data server. During the measurement process, the RCX team can work with the operators on site to better understand the limitations and characteristics of the site equipment, thus providing the client with tailor-made energy-saving opportunities. Not only do the energy-saving opportunities improve energy efficiency, but they also strike a balance between cost-effectiveness and on-site constraint. While carrying out measurement, the measurement team can identify potential energy-saving opportunities through the measured data and issues identified during the measurement. Common examples of potential energy savings opportunities. Optimization of HVAC operation schedule. Based on the actual usage of the building and seasonal changes, the operation hours of the HVAC equipment can be reduced to avoid unnecessary energy consumption. Optimization of AHU return air temperature set point. When the room temperature keeps lower than CCMS set point, the AHU return air temperature set point can be adjusted to reduce unnecessary energy consumption due to overcooling provision. Fresh air demand control. If the average CO2 concentration is far below what is specified, there would be a room to reduce the fresh air intake by using variable speed drive for AHU fan speed control. Fan static pressure reset. When cooling demand is low, the static pressure setting of AHU can be further adjusted to save AHU energy. Throughout these potential energy-saving opportunities, unnecessary energy consumption can be reduced based on the building's mode of operation to improve system efficiency. After the measurement team has obtained the relevant data, specific recommendations can be provided to the responsible person of the premises to help them improve system efficiency in order to ensure equipment is operated in optimal conditions. Power consumption can be reduced, saving energy as well as operating cost. In conclusion, retro commissioning brings a number of benefits, and we hope more buildings can improve energy efficiency through RCX. Energy consumption and carbon emissions can be reduced significantly, while goals of sustainable development and carbon neutrality can be fulfilled, making Hong Kong a more livable city.